Johnny here with Simpson Math. In this video, I'm going to explain completing the square. Basically, I'm going to give you an expression, some trinomial or something like this, where it's not a perfect square trinomial, but we're going to make it one so that we can factor it. And I'm going to start off with some simple examples, but I'm going to do every example is going to be a little bit step harder or some new caveat that we've got to address. So let's just get started. I've got x squared minus 8x plus 3. Trinomial. I want to know, is this a perfect square trinomial? So I can kind of go off to the side and say, the a in this game is x. My b would be the square root of 3. That's the root of 3 times the root of 3 would give me this 3. And then does 2ab equal negative 8x, or an 8x value? Well, that's 2 root 3x, so no. This is not a perfect square trinomial, so we're going to make it one. Now, right now, I have an expression. This is not an equation, this is just some expression. So if I want to start to manipulate it, I only have two options. I could multiply by 1, not changing the value, or I could add 0, not changing the value. So I think I'm going to do the adding 0 process. So first I'm just going to kind of rewrite this trinomial in preparation of what we call completing the square. So I have the quadratic term minus the linear term, and then I'm going to add the number that makes this a perfect square trinomial. Now I still have a plus 3, and if I just add a random number, that changes the value. So what I would need to do is subtract that same number right back off. If I add 5 and then subtract 5, that's just adding 0. I'm not changing the value. All right, now what number should I add there? Well, I like to just show this little notation where I take half of the coefficient of the linear term. So half of negative 8 is a negative 4. And I do worry about the sign here, if it's positive or negative. That negative 4 is going to be important in a second. Then I'm going to square that value. That is negative 4 times negative 4, and I'm going to get 16. I claim these first three terms are a perfect square trinomial. Now if I add 16, I've got to subtract that 16 right back off. That doesn't change the value of it. Now, if I kind of zoom in on this trinomial here, the first three terms, I claim that is a perfect square trinomial. Meaning, what I have underlined in red, that first term, the a value being squared, that would be x. b, well, I've got 16 over here, so 4 squared would give me 16. And then twice ab is 2 times 4, 8x. That's that value I need. So what I have underlined in red is a perfect square trinomial, and we know that those perfect square trinomials factor very nicely. So I'm just going to go straight to the factored form, which is going to be x minus 4 squared. So I took what's underlined in red and I factored it, just using my knowledge of perfect square trinomials and how they factor. Now the positive 3 and the negative 16, those are integers. I can combine them together. 3 minus 16 is a negative 13. And we've done it. We call this completing the square. Completing the square. All right, let's do that again. While I write down the next problem, what we have here, some of y'all may think is very familiar. We've got this quadratic now. So this quadratic, if I were to say like y equals this stuff, that equation, where that parabola is now written in a vertex form, if that rings a bell. That's just a translation left and right. That's a translation up and down. That's kind of where we're headed. All right, but back to the video. We need to complete the square. So my next example is no longer an expression. I now have an equation. Y equals 3 times x squared plus 2x plus 2, where x squared plus 2x is in parentheses. All right. Well, okay. What I'm going to do is I'm going to focus in on the quadratic term and the linear term. And I want to rewrite that as a perfect square trinomial. So I'm just going to rewrite what's inside that binomial, that quadratic binomial, as a perfect square trinomial. And when I do so, I want that coefficient to be 1. So right now, that 3 is not, like it's been factored from the two terms. So I claim that the coefficient of this x squared is 1. I'm just going to write that down though. Make sure coefficient on quadratic term is 1. In our previous example, we had x squared and that coefficient was 1. We have 1x squared. Here, we're safe because that 3 is not really in front of the x squared. It's 3, I would have to distribute in order for there to be the coefficient. So I'm safe. That means what I would like to do is focus in on inside this parentheses. I'm going to take that binomial and rewrite it as a perfect square trinomial. So I have x squared plus 2x. And I'm going to add a number in here to make what's inside those parentheses a perfect square trinomial. Now if I add a number, like last time, I need to then subtract that number back off. Now I actually have a second option. Because of the equation, I could do something different. If you add 5 to the right-hand side, you could keep it balanced by adding 5 to the other side of the equation. That would work. But I'm going to do the same process, right? Add a number to the right, and then subtract that same number right back off. I like this notation. I'm taking a look at the coefficient on the linear term, and I'm going to half it. Half of positive 2 is positive 1. I'm going to write down the sign. It's important in a second. I'm then going to square that value. Positive 1 times positive 1 is positive 1. And then I need to subtract. Did you just say 1? If I put a 1 inside these parentheses, notice I have that 3 out there. So if you put a 1 inside the parentheses, you're actually adding 3 to the right-hand side of the equation. So to keep this balanced, I'm going to have to subtract 3 as well. So by placing a 1 in the parentheses, I added 3 to the right-hand side. So I need to subtract 3 from the right-hand side. All right. No big deal. I think I can rewrite this now. I still have the 3 outside. What's inside the parentheses, that's now a perfect square trinomial. So I can factor it very quickly. And this plus 1 can be helpful. It's just going to be x plus 1, quantity squared. And then I can combine 2 and 3, or negative 3, to become negative 1. We have completed the square. We took this equation at, this is not a perfect square trinomial, and we've rewritten it as a PST, and we were able to factor it. This form is very helpful in our upcoming videos, where we're going to start to graph these conics, where I can now see this parabola with some transformations. So it's very helpful. Let's continue though. I'm going to throw something else at you. So this time, I gave you new information. Let's let that coefficient be 1. So yeah. And then also, if there are parentheses and you add a number in there, you need to not forget that you're multiplying. Let's see what my next example's got in store for us. Let's try, I'll change up the variables just to confuse you on purpose. We've got x equals 9y squared plus 18y plus 11. looking here, this is a quadratic equation, and this is not a perfect square trinomial. I guess my A in this game is 3y. Let me just do that for fun. A is 3y because 3y times 3y is 9y squared. But B is the square root of 11. The square root of 11 times the square root of 11 gives me the 11. So if I double that, I'm not going to get 18y. I would like, though, to create a perfect square trinomial. Now, when I do, I need to make sure that quadratic coefficient is a positive 1. Right now, it's a positive 9. That 9 needs to be factored out. I need to pull it out. Like in the previous example, the 3 had been factored from these two terms. I'm going to do exactly that same process. I'm going to factor 9 from the two terms with the y variable. I'm ignoring the constant 11. So I'm going to factor the 9 out. That leaves me with 1y squared plus 2y. I'm leaving room because I'm about to complete the square, and then the 11 was not touched. If I were to distribute the 9 back, I would have 9y squared plus 18y plus 11. So make sure the coefficient is 1, factor that number out. Then I think we just go through the same process. I'm going to take half of the coefficient of the linear term, half of positive 2 is positive 1, square that value. I'm going to add 1 inside this parenthesis, so I'm adding 9 to the right-hand side of the equation, so that I then need to subtract 9 right back off. This is a perfect square trinomial, so I can very quickly factor it. It's going to be y plus 1 quantity squared. 11 minus 9 is positive 2. This is some sort of parabola, but it's not, doesn't look like a function parabola. All right, so this one had the factoring step. If your quadratic term has a number in front of it, we really need to factor that out so that our quadratic term has a coefficient of 1. Then we can complete the square, go through that process. Here's my next example. Y equaling 4x squared minus 20x plus 27. A in this game is 2x. B in this game is the square root of 27, which when I double that is not going to give me 20. That's some irrational thing. So I'm going to go through the same process. I'm going to factor the 4, making that coefficient on a quadratic term a positive 1. 4x squared divided by 4 is x squared. Negative 20 divided by that 4, I'm going to get negative 5. I'm going to leave room because I'm about to make that a PST. I still have the 27 outside the parentheses. So I just factored the two terms with an x variable by 4. Now I'm going to go through the process. I'm going to half the value of the coefficient of the linear term. Ooh, now this is not pretty, but I can do it. Half of negative 5 is simply negative 5 halves. Don't go toward decimals. We want to keep it as fractions. They're easier to square. I now need to square that value, or multiply. Negative 5 over 2 times negative 5 over 2 is a positive 25 fourths. Okay? But if I add that number to the right-hand side, I need to subtract that number from the same side. But if I put a 25 fourths inside the parentheses, then 4 times that value, well, that just kind of reduces the 4s. I really just added 25 to the right-hand side, so I need to subtract 25 from the right-hand side to keep that equation balanced. PST factors nicely. Y is going to be equal to 4 times the product, or 4 times the binomial, x minus 5 halves, quantity squared, and that looks like a positive 2. So if you do this little notation, you'll always be able to see the A and the B very nicely. It's easy to factor. So this example was a little bit harder just because the factoring process gave us a fraction. Ooh, scary fractions. All right, let me do, an example with multiple variables. So I have 3x squared plus 4y squared minus 6x plus 16y plus 7 equals 0. Oh, goodness. Okay, this has 2 good new things in it. First of all, I've got multiple variables running around. I've got x's and y's, and they're both quadratic, so I believe I'm going to want to complete the square for both variables, for the x's and the y's. I'm also going to do a little bit different, where instead of adding 0, in all the previous examples, I've added a number and then subtracted it right back off. I think in this example, just to change it up, I'm going to do something different. I'll add a number to the right and the same number to the left to keep that equation true. In fact, before I begin to complete the square, I'm going to just rewrite this. I'm going to get the x's together, the y's together. Any constant, I'm going to move over to the other side of the equation. So I'm just going to kind of pair up my x's, pair up my y's. And then this 7, I kind of want to go on to the other side. I don't want to be in my way. I'm going to subtract 7 from both sides of the equation. Now, before I begin completing the square, those coefficients on the quadratic terms have to be 1. So I'm going to factor a 3 from the x's, and I'm going to factor a 4 from the y's. Oh, that makes it pretty big. All right, factor to 3. So I'm left with x squared minus 2x. I factor a 4, leaving me with y squared plus 4y. Now that the coefficient inside those parentheses is 1, I'm going to go through the motion of completing the square. Half, the linear term, is -1. Square that value to get +1. Now let's think about what just happened there. I put a 1 on the left-hand side of this equation. The 1, though, is being multiplied by 3. So I really just added 3 to the left-hand side of the equation. I'm going to keep this equation balanced by doing the same thing on the right. In an equation, you can do something to the left as long as you also do it to the right. So if I add 3 to the left, I can add 3 to the right. In my previous examples, I did not do this. I took it away from the same side of the equation, so I'm just trying something new. I can complete the square here. Half of +4 is +2. I'm going to now square that value. +2 times itself is going to be a +4. But I really just added 16 to the left, so I need to add 16 to the right to keep that equation equal. These are now PSTs, so I can factor them quickly. X minus 1, quantity squared, plus 4. Y plus 2, quantity squared. Equaling, on the right, I just have a lot of numbers. Let's see, -7 and 3 is -4, -4 and 16 is 12. We have completed the square. In a future video, we'll talk about what this is. This is no longer a parabola, but this is very helpful for when we get to the comics. All right, so I have 3 times the binomial x minus 1 squared plus 4 times y plus 2 squared equals 12. And we have completed the square. I think maybe I'd like to do one more example. Fractions always scare my students. So let's just do one more example, and then I think we can handle any completing the square question after that. So let's try something like 1/3 x squared plus 4/3 x minus 2/3. First thing to maybe notice is that this is not an equation, so I can't do the previous technique. I'm going to have to add 0. Add a number and then subtract it right back off. Another thing to notice is that I don't have a 1 coefficient, so I'm going to have to factor that a out of there, that leading term, that leading coefficient out of there. So I'm going to factor by 1/3. Now factoring is just division. 1/3 divided by itself is 1, so I have 1x squared. This may be a little bit tricky for some of us. 4/3 factored by 1/3, that's just division. So I'm going to come up off to the side and play with that. OTS for off to the side. 4/3, if I factor by 1/3, we're just dividing by 1/3. So some of you may want to keep change flipped. I'm going to multiply by a form of 1 that will get rid of these denominators. I'm going to multiply by 3/3. So in the numerators, 4/3 times 3, the 3's will reduce, so you can think of it as 3/1 if you need to. That's just going to be 4. In the denominator, 1/3 of 3, well, that's just 1. Oh, so we're just getting 4. So 4/3 divided by 1/3 is 4. I'm going to leave room, and I did not touch the 2/3, the negative 2/3. I'm just leaving it alone. So I'm just factoring out that 1/3 from the 2 terms with a variable, like in the previous examples. And factoring is just a division. Don't let it scare you. If you need to go off to the side, do so. All right, now I can go through the motions. Half of positive 4 is positive 2. I'm going to square that value to get 4 right back. Now by adding 4 in the parentheses, I have actually added 4/3. 1/3 times 4 is 4/3. So I need to subtract 4/3 right back off. Well, that's convenient. Thank you, Mr. Simpson, for giving us a common denominator that makes the problem easier. Oh, you're welcome. So now I can, oh yeah, this is factorable. It's a perfect square trinomial. So this will be 1/3 times x plus 2 quantity squared, common denominator. This is going to be negative 6/3. That's just negative 2. So I'll do one last step to pretty this up. And that is very pretty. We completed the square. This process where I take a trinomial or some sort of quadratic term in nature and I introduce or I add a number in some way to make it a perfect square trinomial so that I'm able to factor it and get it into this form, we call that completing the square. All right, I think you're ready for the next video. Bye.